Assalamualaikum warahmatullahi wabarakatuh dan juga selamat pagi kepada semua para pelajar. Okay, Alhamdulillah kita dapat sama-sama hari ini untuk mengikuti kuliah fizik chapter 1 Physical Quantities and Measurement. Okay, and then kita akan go through chapter 2 lah, okay, sebab kita ada half an hour and then half an hour. Alright, sebelum kita mempersilakan Puan Normadia untuk sesi kuliah kita pada pagi ini, saya ingin buat satu sedikit taklimat lah berkenaan dengan pengisian borang kehadiran kuliah. Okey, sekejap ya. Okey, seperti yang Okey, untuk borang kuliah ini, saya ulang lagi sekali untuk borang kehadiran kuliah, sila isi menggunakan KMKK 365. Okey, sekiranya ada masalah, boleh PM Digital Expert KMKK. Okey. And then dekat bawah ni untuk minggu pertama iaitu hari ini, okay, kita buat pilihan kumpulan kuliah. Tapi selepas you all dapat timetable, ada kelas sendiri, so nanti saya akan edit lah mengikut kelas masing-masing. Okay. Seterusnya, okay, perkara yang kedua adalah tajuk video kuliah. So pada hari ini, tajuk video kuliah kita adalah Physical Quantities and Measurement berserta dengan Kinematics of Linear Motion. So apa video yang para pelajar lihat, so sila pilih video tersebut. Okay. So kat sini ada tajuk kuliah sehingga habislah, okay, tapi pilih mana yang berkenaan sahaja. Okay. Seterusnya kita ada nombor 3 dan nombor 4 adalah jawapan. Okay, setiap kuliah kita akan berikan soalan ringkas. Okay, setiap kali kuliah. Okay, ada 2 soalan. Sila jawab. Okay, boleh pilih and then soalan tu rujuk kepada kuliah tersebut. Right, itu sahaja. So harap-harapnya student boleh fokus lah lepas ni. Okay, so tanpa melengahkan masa, saya akan mempersilakan Puan Normadia untuk meneruskan kuliah pada hari ini. Selamat semua.
Hi, Assalamualaikum and good morning everyone. How are you today? Hopefully everything is okay. And I'm Madam Normadia, your physics lecturer, and today I want to explain chapter 1 and a little from chapter 2. Chapter 1, that is physical quantities and measurements. In this chapter, we have 3 subtopics. First subtopic is dimensions of physical quantities. Second, scalars and vector. And the last one is of significant figures and uncertainty analysis. For your information, you will learn 1.3 significant figures and uncertainties analysis in your practical class. Let's start with dimensions of physical quantities. The learning outcome for this subtopic: first, student can define dimension. Second, student can determine the dimension of derived quantity. And the last one, student can verify the homogeneity of equation using dimension analysis. Do you know what is dimension? Dimension is to indicate how physical quantities related with its basic quantities. Okay, maksudnya di sini dimension adalah salah satu cara macam mana kita nak menghubungkaitkan kuantiti fizik dengan kuantiti asas. I have one example today for you to show the relationship of physical quantities relate with its basic quantities. I chose velocity. As you know that velocity is a displacement over time, and velocity is a derived quantity, then displacement and time is a basic quantity. From this example, we can see that velocity related with displacement and time, where velocity is derived quantity related with its basic quantity. Class, now we want to learn how to write dimension. We have two simple steps to write the dimension. First, you need to use the square bracket. Second, you need to put the physical quantities or its symbols into the bracket. For example, displacement or S, which is a symbol for displacement, you can choose either one. You want to bracket displacement or its symbol as, both are correct. And class, we have a note here, and this note state that dimension of dimensionless constant is 1. Okay, di sini dimensionless constant contohnya adalah number. Number 1, number 2, number 3, apabila kita dimensionkan sebarang number ataupun constant, nilai dia adalah 1. And now let me move to dimension of basic quantities. I'm sure that all of you know what is a basic quantities. We have 7 basic quantity. First, we have length. Then we have temperature, mass, time, current, amount of substance, and luminous intensity. Did you notice when I want to dimension the quantities, we need to put square bracket. And the symbol of a dimension for length is capital L, theta for temperature, capital M for mass, capital T for time, capital A for current, capital N for amount of substance, and capital C for luminous intensity. Student, you need to remember this symbol. Why? Because we will use this symbol for dimension of derived quantity. As I mentioned before, we need to remember the symbol of dimensional symbol of basic quantity to write dimension of derived quantity. Like we see example 1. What is dimension for velocity? First, you need to identify the formula for velocity. Velocity equals to displacement over time interval. And then what we need to do is we need to put the square bracket between the quantity. Or if you use a symbol, you need also to put the bracket between the symbol. And then what we need to do is we need to replace dimension with its symbol. Dimensional symbol for displacement or distance or length represented by capital L, and then for time represented by capital T. As a result, we will get LT to the power of negative 1. You will get the same answer if you dimension its symbol, which is a LT to the power of negative 1. Now we can see another example of dimension of a derived quantity. We have force, we have work, we have acceleration, and the others. In our syllabus, dimension is used to determine whether a physical equation is dimensionally correct or not by using the principle of homogeneity. Okay, untuk syllabus kita akan menggunakan dimension untuk menentukan sama ada persamaan kita didimensionkan dengan betul ataupun tidak dengan menggunakan kaedah homogeneity. What is a homogeneity? So homogeneity can be described as dimension on the left hand side of the equation equals to the dimension on the right hand side of equation. So homogeneity adalah dimension di bahagian sebelah kiri persamaan sama dengan dimension di sebelah kanan persamaan. Let me see the example. By using dimensional analysis, check whether the following equation is homogeneous or not. Given equation is V equals to U plus AT. First, you need to locate which quantity at left hand side and which quantity at right hand side. For this equation, V as a final velocity located at the left hand side and U and AT located at right hand side. Then we continue with the solution. We need to dimension left hand side first. We have V final velocity equals to S over T. Then we need to put the square bracket or dimension on that symbol. After that, we replace dimension with dimensional symbol. And finally, we get LT to the power of negative 1. After we finish dimension left hand side, we need to dimension right hand side. We start with U, which is the initial velocity is same equation with a final velocity, U equals to S over T. We will repeat the same process to dimension the symbol, and finally we get LT negative 1. Then we dimension AT. A is stand for acceleration, which is equal with V over T. We dimension the symbol, and then we can cancel up T at the top and T at the bottom, and finally we get LT to the power of negative 1. Since dimension of left hand side equals to dimension of right hand side, therefore this equation is homogeneous. Okay, para pelajar, awak kena pastikan dimension di sebelah kiri sama dengan dimension di sebelah kanan. Okay, apabila dimension di sebelah kiri sama dengan di sebelah kanan, kita boleh katakan bahawa persamaan tadi adalah homogen. Let me proceed to the next subtopic, which is a scalar and vector quantity. I'm sure that most of you has been heard this scalar and vector quantity, right? Okay, what is the learning outcome for this subtopic? First, student can define scalar and vector quantity. Second, student can resolve vector into two perpendicular components, x and y axis. C, student can illustrate unit vector ijk in the Cartesian coordinate. D, student can state the physical meaning of dot or scalar product. A dot B equals AB cos theta. And the last one, student can state the physical meaning of cross or vector product. A cross B equals AB sin theta. Do you still remember what is a scalar quantity? So scalar quantity we can define as a quantity with a magnitude only or with a numerical number with the unit. Let me see this example. The volume of this box is 32 meter cube. 32 sure or 32 is a magnitude or size, and meter cube is SI unit. Another example is the energy of this lamp is 15 joule. Can you state which one is a magnitude and which one is SI unit? Yeah, of course, 15 is a magnitude or size and J or joule is SI unit. Besides these two examples, we have another example such as a speed, temperature, mass, current and distance and etc. Okay, kita ada banyak lagi contoh bagi skala quantity. And now, what is a vector quantity? Vector quantity is a quantity with both magnitude and direction. It's different with scalar quantity. Let me see a first example. A car drives on a straight road heading due east at 60 meters per second. We interpret into the diagram and we can see that 60 meters per second is a magnitude and east is the direction of the car. I proceed with another example for vector quantity. A man is pulling the wooden curtain by applying a force of 50 Newton from position A towards the west direction. So we can say that 50 Newton is the magnitude and to the west is the direction. From this example, we can differentiate between vector and scalar quantity, where vector quantity have a direction, but scalar quantity just have magnitude. And another example for vector quantity such as a displacement, momentum, impulse, acceleration, force, and etc. So boleh nampak ya perbezaan di antara skala kuantiti dan juga vektor kuantiti. Skala kuantiti tadi kita hanya ada magnitude, nilai saja ataupun number. Berbanding dengan vektor kuantiti kita ada nilai, number dan juga dia punya arah. How to present a vector? A vector can be presented by draw the arrow. This arrow have a two part, tail and head. The length of the arrow will give us a magnitude of the vector, while the direction of the arrow will give us a direction of the vector. Consider I have vector S and I can write as bold print, or I can write with the arrow above it. If you want to find the magnitude for a vector, what we need to do is we put the modulus beside the symbol. As we know that vector is a quantity that have a magnitude and direction, and how we want to state its direction. So the direction of the vector can be stated according to direction of compass, such as to west, to east, to north, to south, and etc. Okay, kita boleh mengikut arah kompas. And the second method, or beside that, we also can state the direction of the vector by denote with positive or negative sign. If you want to denote with a positive or negative sign, we need to refer x-axis and y-axis. Okay, kita boleh tandakan juga vektor ni, arah vektor dengan tanda positif ataupun tanda negatif. If your vector is positive, it shows that your vector is upward or to the right. To the right. If the vector to the left, it will give you negative sign. It's same with if the vector is downward, it gives you a negative sign. Ya, kat sini apabila vektor kita arah dia ke atas ataupun ke kanan, kita boleh tandakan dia dengan positif. Okey, manakala apabila vektor kita ke kiri atau ke bawah, kita boleh tandakan dia dengan tandaan negatif. Besides that, we also can state the direction Okay, minta maaf ya, kita ada sedikit masalah teknikal, jadi saya sambung balik tadi. Another method, if you want to state the direction of a vector, we can use angle with a reference line. For example, a boy throws a stone at a velocity of 20 meter per second, 50 degree above horizontal. Okay, kita refer kepada gambar raja yang diberi sini ya. Okay, para pelajar boleh nampakkan direction of velocity with 50 degree above horizontal. Horizontal represent x-axis, vertical will represent y-axis. Okay, ini juga adalah salah satu cara macam mana untuk kita tentukan arah vektor. If you see this vector, vector A that we drawn at the angle, what do you think? Apa yang kamu fikir kalau kamu nampak vektor yang bersudut? Of course, this vector will have two components, and this component or this part we call as a vector component. Okay, let me see what is the component of the vector. We have component x, which is a ax, and we have component y, ay. Ya, kat sini vektor A mempunyai dua komponen, komponen X dan kita labelkan dia sebagai AX dan juga komponen Y kita label dia sebagai AY. The process to find the components of a vector we call as resolving a vector. Okay, ataupun kita panggil dia sebagai leraian daya. For example, a bar is pulled by a force at the angle theta. And how we want to find the components of a vector. First of all, you need to sketch x and y axis, and then you draw the vector f with the angle. After that, we resolve to x component and y component. By using theorem Pythagoras, fx over f equals to cos theta, then we rearrange the equation to get fx equals f cos theta. Same with fy over f equals sin theta. Rearrange the equation, fy equals f sin theta, where theta is the angle of the vector. Alright class, if you want to calculate the magnitude of the vector, we use the formula square root fx square plus fy square. Then we can find the direction of a vector f by using the formula tangent theta equals to fy over fx or arctangent fy over fx. Fy is the force at the component y, fx is the force at component x. Let me see this example. A particle has experienced a force of 100 Newton as shown in figure above. Determine the x component and the y component of the force. Solution for this example, we draw the force and then we resolve to component x and component y. We label fx and fy. Okay, for fx, is equal with negative f cos theta. Why is negative? Did you notice that the direction of fx to left? That's why we put negative sign into the equation. And then you substitute the value of f that is given from the question, 100 Newton. And the angle is 30 degree. We use a 30 degree. We do not use 150 degree. We get negative 86.6 Newton. For y component, we can write as Fy equals to F sine theta. Did you notice that at y component, your F is positive? Why this a positive? Because of the direction of Fy is upward. So we need to put positive sign. Then you replace the value of F into the equation. And finally, we get 50 Newton. Okay, this is how we want to find X component and Y component. We also have a unit vector, where unit vector is a vector that has a magnitude of 1 with no unit. Its purpose is only to describe a direction in space. The symbol of unit vector is hat, A hat, P hat, or C hat. Let us see unit vector in XY coordinate system or 2D system. Consider we have vector S, and then the pink arrow is X component. The blacks represent Y component. So the unit vector for I and j points in the direction of X and Y axis and have a magnitude of 1. I represent for X axis, J represent for Y axis. How you want to write the equation? The general equation, if you want to write in terms of unit vector, is become as S equals to Sxi hat plus Sy j hat. For example, again with the same vector S, for the X component or Sx, the value is 4 meter, and for Y component or Sy is 3 meter. We can write as S equals to 4I plus 3j meter. Let me proceed with a unit vector for 3 dimension. For 3 dimension, it will have a z-axis, which is represented by k, unit vector k. I for s-axis, j for y-axis, and z for k-axis. Now we have a vector s, and we can write the general equation for unit vector for 3 dimension is S equals to Sxi plus Syj plus Szk. Then you just substitute the value for Sx, Sy, and Sz. We know, you know, I know that vector can be add. Vector also can be subtract. And now, what we want to do is vector can be multiplied. The multiplication of vector will produce scalar or dot product and vector or cross product. Ya, vektor juga boleh di multiply, hasil darab vektor. Okay, menghasilkan dua jenis vektor, scalar product dan juga vektor product. The example for scalar product is a work done. I have a box which is pulled by 5 Newton at the angle 25 degree along 1 meter. And work done by the force is F cos theta F. You substitute the value of F and S and then you will get 4.53 joule. 4.53 joule is the magnitude. It shows that scalar product is scalar quantity. Ya, untuk scalar product dia hanya menghasilkan magnitude sahaja, nilai sahaja dan kita panggil dia juga sebagai scalar quantity. Tak ada arah, hanya ada magnitude ataupun nilai sahaja. Then the physical meaning of the scalar product, we consider that we have two vector, vector A and vector B separated by theta, angle between A and B, and then we project vector A on vector B, we get A sine theta. Therefore, A dot B equals to magnitude of vector B multiplied by the component of vector A parallel to vector B. For your information, scalar product also we known as dot product. And then the equation is B multiplied with constant of A parallel to B. So parallel to B is A sine theta. Your equation become B A cos theta. And we also can write AB cos theta. Theta is the angle between A and B. Or A dot B also equal with a magnitude of vector A multiplied by the component of vector B parallel to vector A. You will get the same equation which is AB cos theta. The keywords for scalar product or dot product is parallel. The scalar products obeys the commutative law of multiplication. A dot B equals with AB cos theta, B dot A equals with BA cos theta. So A dot B equal with B dot A. Okay, ini kita masukkan dengan commutative law of multiplication. Okay, dia akan beri nilai yang sama iaitu number saja. Kalau A dot B sama dengan 4, B dot A juga adalah 4 sama. Okay, the angle theta range from 0 degree to 180 degree. Okay, the scalar product can be positive, can be negative and can be 0 according to the angle. And how about vector or cross product? The physical product meaning of the vector product is A cross B equals to magnitude of vector A multiplied by the component of vector B perpendicular to vector A. For your information, vector product also we known as cross product. The keywords for vector product or cross product is perpendicular. So we can write AB sine theta. Okay, B sine theta perpendicular with A. So AB sine theta. Theta is an angle between vector A and vector B. How we want to determine the direction of cross product? As we know that cross product or vector product is a vector quantity. So it will have a magnitude and direction. We have two methods to determine the direction of cross product. Kita ada dua cara untuk tentukan arah bagi cross product. Okay. Kaedah yang pertama, we can use right hand rule. Okay, semua boleh angkat tangan kanan. Okay, right hand rule seperti dalam gambar rajah. Di atas tu. Okay, point the four fingers to the direction of the first vector. Swipe the four fingers from the first vector towards the second vector. The thumbs show the direction of the vector product. Okay, empat jari yang kat ujung tu, okay, dia mewakili vektor yang pertama. Kemudian tapak tangan awak mewakili vektor yang kedua dan ibu jari awak adalah vektor yang dihasilkan. Okay, let me see this figure. A cross B, A dekat jari yang hujung, A dia, okay, A B, A cross B, A cross B. Okay, kita swipekan empat jari kita tadi ke vektor yang kedua. Okay, kita akan dapat vektor barulah yang ibu jari kita tu. Okay, A cross B will get vector C. Okay, what happen if B cross A? Dia akan menghasilkan vektor yang sama juga. B cross A tetapi arah yang berlainan. Okay, different directions. Second method, you can use a corkscrew method. A cross B, okay, A cross B, we will get a new vector C, and A cross B is like anti-clockwise. Okay, kita dapat arah dia adalah anti-clockwise, so C kita ke atas, and then B cross A, okay, direction dia kita seperti kita putarkan skru tu, arah dia adalah arah ikut jam. Ya, itu clockwise. So direction dia ke bawah. The direction of the vector product C always perpendicular to the plane contain A and B. Okay, sentiasa perpendicular, sentiasa bersudut tepat 90 darjah. Okay, kepada plane yang ada vektor A dan juga vektor B. Okay, yang ni yang perlu awak ingat ya. A cross B is not same with B cross A, but A cross B equals with negative B cross A. Kenapa tak sama? Sebab direction tadi ya. Ini adalah vektor quantity, so direction dia tak sama kat sini. Jadi A cross B takkan sama dengan B cross A. Alright class, we proceed with chapter 2, Kinematics of Linear Motion. Okay, dalam chapter 2 saya hanya terangkan subtopik yang pertama sahaja, 2.1, Linear Motion. Okay, what is a linear motion? Linear motion is defined as the studies of motion of the object without considering the effect that produce the motion. Okay, kita hanya belajar tentang objek yang bergerak tanpa mengambil kira apa yang menghasilkan pergerakan tersebut. Learning outcome for this subtopic first, student can define instantaneous velocity, average velocity and uniform velocity, instantaneous acceleration, average acceleration and uniform acceleration, we student can discuss the physical meaning of displacement time, velocity time, and acceleration time graph. And the last one, student can determine the distance traveled, displacement, velocity, and acceleration from appropriate graph. So kita ada 3 hasil pembelajaran untuk subtopik yang pertama bagi chapter yang kedua. Let me see what is a velocity. So the velocity of the body is the displacement of the body in unit time. Velocity is a vector quantity and the SI unit for velocity is meter per second. Okay, semua orang tahu kan maksud velocity ni apa dan juga dia punya SI unit. Okay, in velocity, we have 3 types of velocity. We have a constant velocity, average velocity, instantaneous velocity. Constant or uniform velocity. Okay, what's a uniform or constant velocity? We can say that if a body covers equal distance in equal interval of time in a given direction, said to be uniform. Let me see this diagram. Okay, I have a 3 point A, B, C. Okay, a man running from point A to point B with 3 meter in 3 seconds. Then he continue run from B to C with the same distance and the same time. A to B 3 meter in 3 seconds, B to C 3 meter in 3 seconds. So the velocity that we can calculate equals to displacement over time, you'll get 1 meter per second. It shows that the velocity from A to B equals to 1 meter per second, B to C also 1 meter per second. So as a result, this is a uniform velocity. A, B, B, C have a same velocity. And the formula for uniform velocity, we can use V equals to S over T. S is displacement, T is time. Another type of a velocity is an average velocity. Let me see this example. Say that it's a beautiful day and you decide to go for a run. During your first hour, you run 5 meters at a constant pace. During your next 2 hours, you run 16 meters at a new constant pace and your average velocity is, okay, look at this diagram. For the first hour, you run 5 meters. From start point to S1 is 5 meters, it takes 1 hour. And then next 2 hours, you continue run with 16 meter. Okay, kemudian awak lari lagi sebanyak 16 meter. So the total displacement for this case is equal with 16 meter and total time equals to 2 hours. Okay, 1 plus 2 will get 3 hours. And then total time 2 hours. The average velocity is 8 meter per hour. The formula that we can use for average velocity, S2 minus S1 over T2 minus T1. S2 is a final displacement, S1 is the initial displacement, T2 is the final time, T1 is the initial time. And then we proceed with the instantaneous velocity. Instantaneous velocity, we can state that velocity at a particular time or moment in time. Okay, semasa kita lari, kita punya laju kita tak sama. Okay, pada masa yang pertama mungkin 6 meter per second. Pada masa yang kedua mungkin 3 meter per second. Okay, sorry kat sini meter per second bukan ms1. Negatif tak ada kat situ. Okay, kemudian untuk masa yang ketiga adalah 9 meter per second. Jadi instantaneous velocity ni adalah laju yang kita lihat pada masa tertentu. Contohnya kita nak lihat pada T1, maka V dia adalah 6 meter per second. Okay, formula for instantaneous velocity, limit of AS over AT approach to 0. Next, we proceed with acceleration. Acceleration is the way or speed change or how fast the speed is changing. Okay, apabila laju kita bertambah ataupun berkurang, maka objek dia akan memecut. Okay, acceleration is a vector quantity and the SI unit for vector quantity or for acceleration is meter per second squared. Same with velocity, acceleration also have three types. Ada tiga jenis. We have a constant acceleration, average acceleration and instantaneous acceleration. Let me see what is a constant acceleration. A velocity that change by the same amount of each second. Perubahan laju yang sama pada satu masa. Okay, let me see this example. Saya ada satu contoh di sini ya. Okay, this car move from A to B with 2 meter per second at the first second and then continue with 4 meter per second in the next second. Okay, nampak daripada A ke B, laju dia adalah 2 meter per second. Daripada B ke C adalah 4 meter per second. So, the velocity increase with 2 meter per second during each second. Okay, which is A equals to velocity 2 divided by 1 second, we get 2 meter per second square. Okay, you can use the formula A equals to V over T, where A is acceleration, V is velocity, T is time. Another type of acceleration is average acceleration. Average acceleration we can state as or define as a rate at which velocity change over a specified time interval. Okay, for example, if the velocity of a ball increase from 0 to 6 meter per second in 3 seconds, the average acceleration of the ball would be 2 meter per second. Okay, macam mana kita dapat 2 meter per second? Kita akan guna formula V over delta V over delta T. So V kita adalah 6 tolak kosong bahagikan dengan 3, you akan dapat 2 meter per second. 2 meter per second square kalau untuk velocity. And the last one for acceleration is instantaneous acceleration. Instantaneous acceleration, we can state that the acceleration at a particular time along the path of a motion. Okay, sama macam velocity tadi. Pecutan berlainan pada masa yang berlainan. Okay, kat sini kita boleh lihat pada kedudukan A, position A, pecutan dia adalah 80 meter per second. Pada B, 60 meter per second, pecutan dia berkurang kemudian bertambah. Okay, pada C, 950 meter per second square. Okay, Okay, definition of instantaneous acceleration is the limiting value of average acceleration over the interval of time which approach to 0. You can use this formula. Okay, for the second subtopic is about a graph. Okay, graph, we have three types of graph. Displacement against time graph, S against T, where S axis is time, represented by time, Y axis is displacement, and gradient of the graph represented by velocity. Second graph is velocity against time. S-axis represent time, Y-axis represent displacement, gradient represent acceleration. Not velocity, is acceleration. This acceleration. And area under the graph is displacement. And the last graph, A against T, S-axis represent time, Y-axis represent displacement, area under the graph represent velocity. Okay, how we want to describe the graph? For situation 1, object is not moving or object is stationary. Okay, we will get, can see this graph, first graph as again T, the velocity equals to 0. And for second graph, V against T, the acceleration equals to 0. When V equals to 0, your A equals to 0. And your graph A, nampak sini graph A adalah kosong. For second situation, object is moving with a constant velocity. Okay, graph S against T. Kita tahu bahawa gradient bagi graph against T adalah velocity. So, boleh cari velocity kat sini. Kemudian untuk graph V against T, gradient for V against T is acceleration. And area under the graph for graph V against T is displacement. Okay, boleh cari luas di bawah graph. Dan graf yang terakhir adalah A against T. Okay, acceleration against dengan time. Okay, bila V kita constant, acceleration kita adalah kosong. And the last one, ni yang terakhir, slide yang terakhir. For situation 3, object is moving with a constant acceleration. Okay, kita boleh nampak bentuk graf di sini di mana gradient dia semakin bertambah. So gradient semakin bertambah, maksudnya velocity juga akan bertambah. Okay, untuk graf yang kedua, V against T, gradient of this graph show the acceleration which is a 2 meter per second square. Awak boleh kira dia punya gradient dia. And area under the graph represent displacement, luas di bawah graph dia adalah sasaran. And A against T, area under the graph for A against T is a velocity. Awak boleh cari luas di bawah graph iaitu mewakili hal laju ataupun velocity. Okey, para pelajar semua, seperti yang Puan Aisyah maklumkan tadi awak akan mengisi borang kehadiran, kemudian awak kena jawab soalan kuis. So ini adalah soalan untuk chapter 1 dan juga chapter 2 sedikit. Chapter 1 saja saya ambil ni. Okay, number 1, dimensional symbol for mass is A, B, C, D. Which one? Capital M, capital T, K or L. Number 2, which quantity is a scalar quantity? Velocity, force, volume or acceleration? Okay, awak catat jawapan sebab nanti awak nak isi dekat borang kehadiran. Okay, sila pastikan awak scan QR code untuk kehadiran dan juga soalan kuis. Okay, itu saja. Bye. Terima kasih. Thank you.